Voyager 1's travels go on in silence, far from Earth. Its signal weakens, but its importance remains. Evidence that human inquisitiveness goes beyond anything we have created. NASA's Voyager 1 is on the verge of a major symbolic achievement in space exploration history. Launched in 1977, this probe has journeyed farther than any other object made by humans. By November 2026, it will be one light day away from Earth, which is the distance light travels in 24 hours. At that point, it will take a full day for a radio signal to reach the spacecraft, and another day for the signal to return. This video will explore what this milestone signifies, what Voyager 1 continues to teach us, and what the future holds. Let's begin. Voyager 1 launched on September 5, 1977, shortly after its twin Voyager 2. The missions were planned to take advantage of a rare alignment of planets, using gravity assists from Jupiter and Saturn to propel the probes toward the outer solar system and beyond. After its planetary mission, Voyager 1 took a quicker path out of the ecliptic plane. It currently travels at about 38,000 mph, or 17 km. This is fast by human standards, but slow compared to light speed of 186,000 miles per second. Over many years, this constant movement has taken Voyager 1 into uncharted territory. In August 2012, it crossed the heliopause, the outer edge where the solar wind ends and interstellar space begins. This marked humanity's first venture beyond the sun's influence. Currently, Voyager 1 is approximately 15.7 billion miles from Earth. By late 2026, it will exceed 16.09 billion miles, equivalent to one light day. This distance is significant because it defines the limit of real-time communication. A single communication exchange with the spacecraft will take 2 full days, one for the signal to go and one for the reply to come back. NASA's Deep Space Network, with its large radio antennas in California, Spain, and Australia, monitors Voyager's weak signals. By measuring tiny Doppler shifts, engineers can determine its precise speed and distance. The one light day milestone is both a scientific and human achievement, quietly demonstrating what persistent effort can achieve. Voyager 1's mission was initially expected to last 5 years. Almost 5 decades later, it is still active, sending faint data from the distant boundary between stars. Though very far from any planet, Voyager 1 is still providing valuable scientific information. Its instruments are still recording the density, temperature, and magnetic characteristics of the interstellar plasma around it. When it first moved into interstellar space, scientists thought it would find a calm, consistent environment. Instead, Voyager found a surprisingly active area where solar storms and magnetic changes still have an effect, even billions of miles from the sun. This discovery changed our understanding of how the heliosphere interacts with the larger galaxy. The probe's plasma wave instrument has detected pressure waves from solar eruptions traveling far beyond the heliopause. Its cosmic ray detector is still studying high-energy particles that come from outside our solar system. Together, this data helps us improve our models of how energy, radiation, and magnetic fields move through the interstellar medium. Voyager 1's durability has also made it a lesson in long-term engineering. In 2017, NASA reactivated backup thrusters that hadn't been used since 1980 to adjust the spacecraft's direction. The maneuver worked at a distance of over 15 billion miles and extended the mission's life by several years. The probe's main limitation is power. It uses a radioisotope thermoelectric generator, RTG, which turns the heat from decaying plutonium into electricity. Each year, the power output drops by about 4 watts, forcing NASA to shut down less important systems. Eventually, even the communication transmitter will stop working. However, as of 2025, Voyager 1 is still gathering and sending important data from a region that no other spacecraft has reached. It serves as a unique source of information for studying the edge of the sun's influence, a natural place to test how stellar winds interact with the interstellar medium. Even with decreasing power, the remaining sensors, especially those for cosmic rays and plasma, continue to provide useful scientific readings. Every signal received from that distance confirms what the mission has always represented: persistence, precision, and a willingness to keep listening, no matter how weak the response. Voyager 1's upcoming achievement shows how vast interstellar communication is. Being one light day away means engineers can't make quick fixes anymore. They must plan each instruction days in advance. Getting confirmation for each response takes almost 2 days. It's a slow conversation across space and time, relying on patience and careful planning. NASA plans to keep Voyager 1 running as long as it can power at least one device. Around 2036, its energy will be too low to communicate. After that, the spacecraft will continue silently, drifting outward at about 3.6 astronomical units each year, which is about the distance from the Sun to Jupiter. In about 300 years, Voyager 1 will reach the inner edge of the Oort cloud, a huge area of icy objects forming the solar system's outer boundary. Traveling through it could take another 30,000 years. Beyond that is open interstellar space, where the spacecraft will travel forever, its path unchanged unless a distant star affects it. Currently, its path points toward the constellation Ophiuchus, and around the year 40,272 AD, it will pass within 1.7 light-years of a star in Ursa Minor. By then, it will no longer work, but its journey will still represent human exploration. Inside Voyager is the Golden Record, a copper disk with sounds, images, and greetings from Earth in 55 languages. It's a time capsule, a message to any civilization that finds it. Even if it's never found, it symbolizes humanity's curiosity and desire to connect beyond Earth. Voyager's mission still influences the design of future interstellar probes. Projects like NASA's interstellar probe concept build on its legacy, aiming to study the heliosphere's outer edges with better instruments and power. Voyager 1 practically shows how human-made systems behave in deep space over decades, and how electronics, propulsion, and communication last in temperatures colder than 200 degrees C. Symbolically, it reminds us that progress in exploration is about persistence, not speed. Voyager 1 survives because it was made to be durable and because people never stopped paying attention. Voyager 1's travels go on in silence, far from Earth. Its signal weakens, but its importance remains. Evidence that human inquisitiveness goes beyond anything we have created.